Hello and welcome back to another Algebra 2 STEM review video. Today I'm going to be going over the quiz review for 7.2 through 7.4. Alright, so let me just get this working. Alright, number 1. Given the function f of x equal 1 over x, describe the transformations on the g of x as 1 over x minus 6 minus 2. Alright, so this minus 6, right, where it's x minus 6 in the denominator, because that's on the inside of the function, it's like you're replacing x with x minus 6, so it'll be on the inside right there. This is going to be a horizontal translation, so translation 6 units right, because when you do minus on the inside, that moves it right. And then this minus 2 out in front is going to move it 2 down. So translation 2 units down. Alright. Number 2. We want to describe the transformations of the same function, the 1 over x. We want to describe the transformations onto g of x equal negative 1 over x plus 3. So now notice we have this negative, right? So that's going to mean, well, first I'm going to take care of what's on the inside of the function. This is a vertical, it's a vertical reflection, right? It's a reflection over the x-axis. But generally you kind of want to, it doesn't really matter the order for this class, but you want to list them in order from horizontal first, and then vertical second. So notice we have a plus 3 on the inside. That means we're going to have a translation 3 units left, because when it's plus on the inside, moves it left. And reflection over the x-axis. That's what this guy's doing. Alright. Alright, for this one, I'm gonna make a pair of axes. Alright, so we have y equals 9 divided by x minus 4 minus 2. And we want to graph it and then identify the horizontal and vertical asymptotes. Well, I'm going to make an x, y table just to get some values. Let's think. What could I plug in? Well, first I just want to, since we have this 0, since we have x minus 4 in the denominator, we're going to have a 0 of 4, when x equals 4 in the denominator, right? Because if you plug in x equals 4, it's going to be 4 minus 4, which is 0. And that'll become 9 over 0 minus 2 will be the whole function, which is not defined, right? So wherever the denominator becomes 0, that's going to be where your function is undefined, which is where you have a vertical asymptote. So I'm going to draw a dotted line right there. So now I'm going to have a vertical asymptote. So x equals 4. Okay. I notice we have a shift 2 down. That's going to shift the horizontal asymptote of 1 over x. Because our parent function, parent function is going to be 1 over x, right? Or y equals. And this minus 2 is going to move it down from it looking like this. It's going to move it, instead of approaching 0, it's going to approach negative 2, right? It's 2 down. So right here will be our horizontal asymptote. That is at y equals -2. Alright. Our domain, well, we know that it can be anything except x values where it's at the vertical asymptote. So that would be, there's two ways, there's a lot of ways you could write it, really. But often what you can just do is you can just say x does not equal 4. Another way, if you take a like college algebra class, this is called interval notation. You could do domain is x such that x does not equal 4. Or if you want to do interval notation, that'd be -infinity to 4 union 4 to infinity. So it's everything, all of the real numbers, but there's a hole at 4, right? Or a hole in the number line. Okay, and the range is going to be everything except -2, because it's going to get really, really, really close to it, but can never equal it. So that would be, you could say y is not equal to 2. Sorry, -2. Another way you could write that is y such that y does not equal -2. It's a little more formal, has those curly brackets. Or another way would be -infinity to -2 union -2 to infinity. So everything, but we're just having that gap where -2 is, right? Okay. So, thinking. Let's try, let me just label the 4, 5, 6, -1, -2, -3, -4, -5, -6. This is 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. Alright. So let's think. If we plug in, let's try 6. I think that might give us something nice. So that'd be 9 over 6 minus 4. So 9 over 2. So it'd be 4.5 minus 2, which would be 2.5. So that would be a point. Let's try 2. That'd be 2 minus 4, right? On the denominator, which would be -2. So 9 divided by -2, that'd be -4.5 minus 2, so -6.5. So that'd be, we're at 2. So that'd be about right there. Let's try 1. So that'd be 9 over 1 minus 4. That would be 9. I'm just going to get rid of this table, because it would be best to use your calculator to get some points. I'm just doing my head. So 9 over 1 minus 4 would be -3. So 9 over -3, -3 minus 2, -5. And let's try 0. So that'd be 9 over -4. So negative 2.25. So that'd be negative 4.25. Alright. Let's see, if I plug in 5, that would give me 9 minus 2, so 7. So that would be right there. Let's think, are there any other points? Negative 5 I could do. Negative, because 9 over negative 5 minus 4 would be 9 over negative 9. So negative 1 minus 2, so negative 3. Okay. So it's going to look something like, on this side, don't forget those arrows. It's going to look something like that. And then something like that. Generally, you want more points than this. Say if I can get one more, 7 minus 4 would be 3. So 9 over 3. So 3. So that'd be 1. At 7, it'll pass through 1. Yeah, so it's best to try and get at least 6 points, 3 points on each side of the. That's not great. Something like that. Yeah, you want to get at least. Okay, one more time. Something like that. This is hard because of the 9, but I could have changed the scale of the y-axis, but usually the numbers will be a little nicer and the points will all fit on the graph. But anyways, you want to get 3 points on each side of the vertical asymptote usually to be accurate. Alright. 4 and 5, we want to simplify the expression. So what I'm going to do for this one, I'm going to take out an x from the top, so it leaves me with x times 3x. And over here, I'm going to take out an x from the bottom, so that'd be 5x plus 2. So let's cancel out those x's, but remember, we're gonna have to give a restriction, right? So this is. So that's gonna be cannot be 0, because if x is 0, you'll have 0 over 0, which is undefined, right? Sorry, my cat is meowing. 3x over 5x plus 2. That is the answer. The only reason why you need to list the description, the restriction, is, well, generally you only need to list it if you're canceling something out and then it's not left anymore. But it's always good to, even if you're not told to. Like here, if when the denominator is 0, that's going to cause something over 0, which is always going to be undefined. So we want to find where that's equal to 0. So 5x plus 2 equals 0. That means that x is equal to negative 2/5. So that means x can't be negative 2/5, because that would be a 0 of the denominator, which would lead to it being undefined, right? Alright. For this one, I'm going to take out an x from the numerator. It's going to leave me with x minus 3. And then I'm going to factor this by thinking what multiplies to 1. So 1 out front. Times 6. So just what multiplies to 6 and adds to 5. I'm thinking 3 plus 2 is equal to 5. 3 times 2 is equal to 6. Yep. that works. So we can factor this as x plus 3 times x plus 2. And it seems like we only have a restriction when x cannot be 3 and x cannot be, sorry, negative 3 and negative 2. So if you plug in negative 3, that will cause this to be 0. If you plug in negative 2, that will mean that this becomes 0. So x can't be 3 and x can't be negative 2. Alright, 6 and 7, we want to find the product slash quotient. Alright, so I think it's always good to try and like cross things out, but then make a note of how many of each thing you have left. So like, here's what I mean. I can get rid of, I can cancel this out with this, but then I'm going to be left with y squared, because this is a 2 and this is a 4. So if you take 2 away from that 4, it leaves you with y, just 2, right? Second power of 2. Because when you divide, like, when you're canceling this out, when you take y to the 4th and divide by y squared, you get y squared, right? And then over here, you have a y squared and you have a y squared, so those will cancel out. With this almost fully cancels out with that, but we have an x to the 1st power left. And then this guy can cancel with this, but then this will be left with x squared on the top. We don't have any more y's on the top, so this is going to stay. We don't even have any more x's on the bottom, so this is going to stay. 54 divided by 9, that's 6. So this cancels and leaves you with the 6. And that's the only like number that we have left down there. So all in all, we're going to combine all these to make 6x squared over y cubed. And that is the final answer. Alright, now we are dividing, right? So this is going to be the same thing as, or actually, I'm not going to rewrite the whole thing. This is the same thing as multiplying by 6x cubed. Wait, I gotta see what it was. 6x cubed over x minus 3. Same thing as multiplying by it, right? Okay. So now what I'm thinking is we gotta do some factoring. So I think there's gonna be some cancellations, but we just, oops, that is the wrong thing. I'm thinking there's going to be some cancellations, but we just can't see them yet. So, on the top, we want to think what adds up to negative 6 and, multiplies to negative 6 and adds up to negative 1. Numbers I think of are negative 3 and 2, because negative 3 times 2 is equal to negative 6, and negative 3 plus 2 is equal to negative 1. So that works. So, I can rewrite this as x minus 3 times x plus 2. Down here, I can factor a 3x to the 3rd. And that leaves me with x plus 2. Okay. Times 6x to the 3rd over x minus 3. Now, notice a lot of these things are going to be able to cancel, right? So, or actually, for this one, I forgot to say it, sorry. For this one, x cannot be 0, and y cannot be 0. But this is the most important one to say, because I forgot it, right? It's best to do your restrictions first before you cross anything off, because we cancel these things out, but that only can cancel if x is not 0. So because we had the x in the bottom at the start, we need to keep in mind that we're going to have a restriction that x can't be 0. So don't make that mistake like I did. Okay. So x is not going to be able to be 3, because that would cause 3 minus 3, which is 0. X is not going to be able to be 0. X is not going to be able to be -2, right? Because that would cause 0 there. But now I think that we can do some cancellations. So it's x plus 2 and x plus 2 will cancel. It's x minus 3 and x minus 3 will cancel. This x cubes will cancel. And this 6 and 3 will cancel to leave it just a 2. Because 6 divided by 3 is equal to 2. So all in all, we have 2, but we have a bunch of restrictions, right? Alright, now we want to find the sum and difference for these. So first what you want to do is you want to factor the numerator and denominator. So let's think what multiplies to -18 and adds to 7. That would be, let me think. I'm thinking -9 and 2. So x minus 9, x plus 2. Because if you add -9 and 2, sorry, I mean 9. Wait, I might have said it right, but wrote it wrong. 9 and -2, because 9 minus 2 is equal to 7, and 9 times -2 is equal to -18. Plus 6 over x plus 9. What I'm going to do is I'm going to multiply the top and bottom of this fraction over here by x minus 2, because then I can have the same numerator, I can have the same denominator, so I can just add these fractions, right? So if I distribute that, this is going to be 14 plus 6x, and then that minus 2, so 6 times minus 2, minus 12 over x plus 9 times x minus 2. That's going to be it's going to be 6x plus 2 over x plus 9 times x minus 2. And that's going to be, let me just factor out that 2, because why not? 2 times x, 2 times 3x plus 1 over x plus 9 times x minus 2. You could expand this out, or you could leave it like that. Those are both correct. Our restrictions will be that x can't be 9, -9, and x cannot be 2, because that's the opposite of those factors, of those numbers in there. Alright, for the difference, it's very similar. I'm going to multiply top and bottom of this by 2, not x squared. I'm going to multiply it by 2x. And for this one, I'm just going to multiply it by 3. Gotta do it to the top and the bottom. So that would be 21 over 6x squared minus 8x over 6x squared. So we have the same numerator and denominator. So that's going to be, we have the same denominator, not same numerator. So that's going to be negative 8x plus 21, right? Because we have a negative 8x. I can bring this inside and just make that adding, because subtracting something, that's the same as just adding the negative of that thing. So negative 8x plus 21 over 6x squared. Alright. And you can't factor that anymore. So the only restriction would be that x cannot be 0. Alright. Final one. Find the expression that makes the following statement true. So, to do this, I'm going to rewrite this. First, x plus 3, I'm going to factor this. So, over, it's an x squared minus 8x plus 12. So we want to think what multiplies to be 12, what two numbers multiply to be 12, and add to be negative 8. I'm thinking negative 6 and negative 2. Because negative 6 times negative 2 is 12, and negative 6 plus negative 2 is equal to negative 8. And we're dividing by this, but that's the same thing as multiplying by the reciprocal. And now let me factor this as well. So what adds up to negative 10. Sorry, what multiplies to negative 10 and adds up to 3? I'm thinking 5 and negative 2. So x plus 5 times x minus 2. And then we have our blank down the bottom is equal to x plus 5 over x minus 6. Alright. So we know that these guys are going to cancel, right? With a restriction that x can't be 2. And then that's all that will cancel, right? But notice if we just multiply this straight across, then this x plus 3 will stay on the top. But in what we have and what we're equal to, we don't have that. So we need to be dividing by x plus 3 so we can cancel that out, right? So if you divide x plus 5 over x minus 6, you get what we have over here. So the expression that makes the following statement true would be x plus 3 up here. So this would be this, or maybe, I'm not sure what they mean, the expression that makes it true, but what goes in the blank is x plus 3. Okay? So I hope that you found the video helpful. I hope that you do good in your quiz. So, yeah, just have a good rest of your day.